Hey physics students, welcome to another edition of Rapid Review for Honors Physics. Today we're going to talk about energy in collisions. So you may recall that when we studied collisions, we studied them in terms of momentum, and we determined, or we learned, that momentum is conserved before and after a collision, right? And that applies to all collisions for momentum. It might beg the question, though, what about energy? How does energy get handled? And I will tell you right now that energy is conserved in a collision only in special cases. It's only when the collision is elastic. So let's check it out. You may remember that an elastic collision is one where things bounce off of each other like these balls do here, and an inelastic collision is like these train cars sticking together when they bump into one another. It turns out that for elastic collisions only, kinetic energy is conserved. I say it kind of three different ways here. These are all saying the same thing. And kinetic energy is conserved only in a special case, not in general. Okay? So for elastic collisions, let's take a look at a collision here as an example and see if we can together figure out whether it is elastic or not. I took data on the left side of this picture. I took data from a student's homework assignment where they were studying momentum, and we have all kinds of situations here. We have two items, red car, blue car. They have certain masses, and they collide, and we have all kinds of data. Without actually solving it today, what I invite you to do, if you have not seen this in class yet, is freeze the video on this slide and look at the right-hand side of it. Look at the collision in terms of energy. You'll get numbers for the red car and the blue car before the collision. You'll get numbers for them after. This is all energy in joules, and of course you can total it, and you can look at delta energy, and in the end you want to see if the change in energy of the system was zero. Okay, so you do that calculation and you can find out whether that was elastic or not. Okay, so spoiler alert, it was elastic. If you got elastic, you're doing well. Okay, here's an example of an inelastic collision. Train bumps into train car, right? Was energy conserved here? No, I guess not, because it's a collision of two things that stick together. That's inelastic, and therefore energy was not conserved. This problem, if you assume a certain, let's see, a certain mass for the train cars, you can determine, I'll reveal the answers here, you can determine the before and after numbers in terms of megajoules of energy. A reminder, mega means 10 to the 6th, kilo means 10 to the 3rd, right? So try those calculations on your own, see if you get the same answers that I got. You will see clearly that this was not an elastic collision because energy was not conserved. Okay, so in summary, kinetic energy is conserved only in a collision, only if it's an elastic collision, a collision that is elastic, okay? And you can look at examples, and I would have to say too that I want to call it perfectly elastic, because there's kind of a middle ground. There's things that kind of bounce off each other and maybe slow down or something and lose energy in the collision. Those are not perfectly elastic. And if you want conserved energy, you have to have a perfectly elastic collision. Okay? One final note, it turns out that a perfectly elastic collision is actually defined as one in which kinetic energy is conserved. So it might seem like I'm talking in circles here, but actually the definition of a perfectly elastic collision is in fact one in which energy is conserved. Okay? And that's all I have today on the topic of energy in collisions. You can do more with that. You can solve problems involving energy and momentum. You can do it in 2 dimensions. You can do all of that. I think what we've done here for today will suffice. Join me next time for our next topic.